Welcome everyone to our fourth virtual live workshop today. We're going to talk about sulfur dioxide concentration using aeration-oxidation method. So the goal of this series is to provide you all the knowledge you might need in your own environment, in your own winery. So to measure sulfur dioxide and making sure you know what to do and how to do in a timeline, in a timely manner. I decided to develop that workshop just to provide you all those knowledge without having to travel and without spending too much time. So we're going to spend 90 minutes today to talk about sulfur dioxide concentration by AO. So I'm still going to use AO for short for aeration-oxidation along the entire workshop. Today, you're going to be able to learn about the roles of sulfur dioxide. So why do we use sulfur dioxide in a winery? And at which step during the process do we need to use sulfur dioxide? You will be able to understand and to explain how the pH will change and affect the forms of sulfur dioxide and how to modify the additions that you will need to make following the pH of your wines. Also, you will understand the risks that are associated with an inappropriate or non-rational use of sulfur dioxide. Then you will learn about how to use the aeration-oxidation apparatus and how to measure free and bound SO2 as well as total SO2. Then we will talk about calculation, and that's a really important section where once you identify how much free SO2 you have or total SO2 you have, you will learn about how to make additions of sulfur dioxide overall. Then you will be able to calculate the appropriate amount of potassium metabisulfite. That's one of the common chemicals we use to add sulfur dioxide in a wine. So we're going to talk about that. And also you will learn about how to recognize the proper waste management. So what's sulfur dioxide overall? So that's a common preservative that is used not only in the wine industry, but really important in the food industry. So in a lot of dry products, dried fruits, you're going to have sulfur dioxide that has been used to preserve that fruit. Sulfur dioxide can be added as a gas. So that's a colorless gas that is a preservative, but that can also be used as a sulfite salt. So that's a powder that we use to add sulfur dioxide, which is the potassium metabisulfite. So that's a powder. That's really soluble in water, and there are a lot of different sulfites form that exist. And we're going to go a little bit more in the chemistry of sulfur dioxide, because that's really important to understand what's the role and how do we make the correct additions. On one side, that's a pretty positive chemical to use because that's a preservative. So that's how you're going to maintain the quality of your wines overall. But it has a con where it's pretty negative for health, especially when you have asthma, for example, because that's a gas that's really irritating your system. And so if you have too much sulfur dioxide, that can be negative for health. So the roles of sulfur dioxide, and probably you already know that. So there are two main roles. The first one is that's an antimicrobial. That means that depending on the form of sulfur dioxide that you will add into your wine, that's going to be able to kill the bacteria and the yeast, some yeast. It depends on the level of sulfur dioxide you're going to use and the form of sulfur dioxide you're going to use. So typical recommendation for the antimicrobial properties are between 0.6 milligram per liter, also ppm, parts per million, of molecular SO2 for the dry red wines, because dry red wines, usually they also have phenolic compounds that are helpful to protect the wines. For white wines, because they don't have a lot of those phenolic compounds, you will need to add a little bit more to have the same efficacy. So you will need to add 0.8 milligram per liter or ppm of molecular SO2. And so I'm going to explain what is molecular SO2 versus other forms of SO2. Also, when we talk about 0.6 milligram per liter of molecular SO2 for dry red wines, you can see there is a star on red wines, and that's because most of the time we consider Vitis vinifera, so the most commonly grown grape varieties that are pretty rich in tannin and in those phenolic compounds. But in hybrids or in interspecific grape varieties that we grow in Iowa and in other states in the Midwest and also in Colorado, most of the time they don't have those tannin, and so their effect on microorganism is less. That's why that level might need to be changed or modified a little bit for hybrid red wines. The second role of sulfur dioxide, that's the antioxidant properties. And so I don't know if that's easy to see on that figure on the right corner of that slide, but the color of this wine is pretty brick brown. So that's a red wine that is pretty oxidized, and that's oxidation is really providing a change of color. So it's becoming more brown, more brick for a red wine. But also that's how you're gonna have that bruised apple smell, the acetaldehyde smell. And that's really something you don't want, because that's a flaw. That's gonna lead to a flaw in your wines. And so you won't be able to sell that wine the same way as if you didn't have that flaw. So to avoid getting oxidation, you use antioxidants. And so sulfur dioxide, that's a really good antioxidant. That's because it's able to bind with enzymes that are responsible for the enzymatic browning. And so the main enzyme that is responsible for browning is the polyphenol oxidase. And so the SO2 or sulfur dioxide is able to bind with polyphenol oxidase. That's one of the enzymes that is responsible for browning. But also it can react with other compounds that are responsible for the chemical oxidation. And so if you use sulfur dioxide, that's going to bind with those compounds, and that will avoid getting that oxidation reaction. So for that antioxidant activity, you would need to use at least 30 ppm or 30 milligram per liter of free SO2. And so you can probably already see there is a difference between molecular SO2, which is the antimicrobial form of SO2, versus the free SO2. Let's talk about molecular SO2, free SO2. What are they? Why are they different terms? And that's because we have a lot of different forms of free SO2 that exist in an environment of wine. So wine it contains at least 10% of alcohol. And so in a water solution, when you don't have alcohol, you have the sulfur dioxide form. So that's based on the pH, but the form of sulfur dioxide is really close to bisulfite form. In water solution, you're going to have more of that bisulfite form. Because of the pH of water, that is more like between 5.7. That's close to neutral. But when you are in an alcoholic solution, so in wine, you're going to have a pH that will have an impact on the form of sulfur dioxide, but you're also going to have alcohol is going to change a little bit that form of sulfur dioxide. But the most important part is really to consider the pH. And so that's where you will have to look at this graph at the same time as this equation. So free SO2 is a combination of three different forms. The first one is molecular SO2. Molecular SO2 is in red in that equation. And so on this graph, that's also in red. This graph is showing how much of those forms are present depending on the pH of your solution. You can see when you have a pH that is really acidic, so really low pH, pH 0 or 1, that's when you have most of the molecular SO2 form, most of the red. So here you can already see that the lowest the pH, the more molecular SO2 you're going to have, which is going to provide you the really strong or the more of the antimicrobial activity. So that's really what you want to have when you're looking for the antimicrobial role. Then when your pH increase, so when you become more in the range of wine pH, so between 2.8, so here it's 3, but between 3.0 and 4.0, that's in this band, that's the wine pH, you see that the molecular SO2 form is pretty low. But still, if you have a pH that is 3.0, you're going to have more molecular SO2 than if you have a pH of 4.0. Then, so the pH change, and when the pH change, if we go back on that equation, So at low pH, you have a lot of molecular SO2. When you increase the pH, you're bringing more and more protons, so hydrogen protons, that are going to convert this form of molecular SO2 into that bisulfite form, HSO3-. That's the chemical structure. This form, so that's in blue, if you go back on that figure, you can see that under the wine pH, that's where you have most of the form of free SO2. So in wine pH, under wine pH conditions, you're going to have a little bit of molecular SO2 at a low pH, a lot of bisulfite form at a higher pH. So the bisulfite form, that's the form that you want to protect against oxidation. So that's the antioxidant form. And that's because the bisulfite form is able to bind with other compounds. So that's the form that can bind with the enzymes, that can bind with anthocyanins, so that can lead to a bleaching effect. That can bind with sugar, residual sugar. That can bind with some acetaldehyde, which is responsible for the oxidation. So you can see that at wine pH, you want those two different forms of free SO2. Then if you keep increasing the pH, you're going to form some sulfite. And sulfite, that's the SO3-2- form, which is rarely found in wine. It is there, but it's really, really low concentration. That's because this form is only formed when you have a pH that is close to alkaline, basic. So overall, free SO2 is a combination of those three forms. So we talk about free SO2. So that's molecular SO2 plus bisulfite form, which is able to bind with other compounds. And because that bisulfite form can bind with other things, that's what is called the bond SO2. And so the addition of free SO2 plus bond SO2 equal total. So when you want to look at just total SO2, you're looking at all those forms. Whatever it's bond or with other compounds, or if it's free. Total SO2, that's what we look for when we want to make sure we are not going over the legal limit. There is legal limit for sulfur dioxide addition. And so the legal limit in the US for total SO2 is 350 milligram per liter or 350 ppm. In Europe, that's slightly different. It depends on the size of wine. And those limits are usually lower than in the US. Also, when you use sulfur dioxide, so as I explained at the beginning, that's pretty negative for health. And so first, you don't want to be over the legal limit, but also it has a sensory threshold of 100 ppm or milligram per liter. That means that if you are over that limit, you're going to have that burning match smell. And that can be considered as a flaw as well. If you have too much SO2, that's not pleasant neither. That's really when you take a sniff of your wine, you might have that really burning match smell or just a sharp odor, and it's covering a little bit the fruitiness of your wine. So you don't want to add too much. So how do we measure free and total SO2 in your wines? So there are a lot of different methods. The first one is the Reaper method, and that's a really old method that is using the titration with iodine. The negative aspect of that method is for red wines, because it's using a blue endpoint. For red wines, it might be challenging to see that change of color. So it can lead to underestimation or overestimation of sulfur dioxide concentration with this method. But it's a pretty quick and easy method using a titration. Another method is using Vinmetrica, and that's the workshop we provided last time. And so that's also using an endpoint, but it's using a system where it's looking at how much, so it's based on the Reaper method, but it's using a system that counts the titration, that helps you in the titration. Another method to measure sulfur dioxide, free and total, or bond and total SO2 in the wines, is the aeration-oxidation method that we're going to use today. So it's really heating an acidified wine and looking at that reaction, that change of molecular SO2 into sulfites or sulfuric acid. So that's the chemistry that's happening. And another method that is pretty new, so now it's not really new anymore because it has been developed 10 years ago, I believe, but that's the headspace gas detection tube, so HSGDT. And we have been providing workshop using that method in the past. It wasn't really consistent. So that's a pretty easy method because it's using just a tube where it's containing a specific chemical that reacts with sulfur dioxide. And so you observe a change of color as well on that tube, but it's taking into consideration just the headspace of a wine, so the volatile portion of sulfur dioxide. And there is a lot of connection that has to be really tight and making sure the gas is not going outside and is really going into the tube. So it's really easy, I would say cheap method, but it has a negative aspect where that's not really reliable so far. So there is still some work that needs to be done on this method. So then, when to measure sulfur dioxide? Because that's good to know what it is for, what are the roles, how do we measure it, and when are we supposed to measure it? And when are we supposed to add sulfur dioxide? So you can measure it and also add sulfur dioxide at harvest, depending on when you decide to process your grapes after harvesting. If you are not going to process your grapes right away, that's good to add a little bit of SO2, either as a powder that you sprinkle on top of it, of your grapes, or as a solution that you spray. Usually you're going to add about 30 ppm or less than 50 ppm or milligram per liter of sulfur dioxide, just to make sure your grapes are protected against oxidation. But also if you don't have really clean fruit, that can help to avoid having the lacase, the enzymes from Botrytis cinerea, that's going to start reacting and leading to bad grapes. So then you can add some sulfur dioxide after alcoholic fermentation if you don't plan to do malolactic fermentation. If you decide to do malolactic fermentation, you will have to wait because the bacteria you will need to add for malolactic fermentation might be killed if you add sulfur dioxide. So make sure you know when or what type of process you decide to do on your wine. There are different levels of sulfur dioxide you can add. Before adding, I suggest to check all the time how much free SO2 you already have, because you don't want to keep adding without checking, because at some point you might be over the limit. So make sure you check, you measure at each step. Same after racking. Racking, that's a process where you bring a lot of air, a lot of oxygen. And so oxygen, that's the trigger for oxidation. And so you need to make sure each time you bring air, you're adding a little bit of sulfur dioxide. So at racking, once again, check how much you already have before adding more. And also at bottling. That's the period of the year, I think, where some of you are bottling right now. So make sure you know how much you have and then add a little bit of sulfur dioxide, so about 30 ppm of free SO2, but it depends on the style, it depends on how much sugar you have, residual sugar you have, because you know, residual sugar, if you don't steroid filter your wine, you might have some bacteria and some yeast that are remaining, and they're going to consume that residual sugar if you don't add any preservative, if you don't add any antimicrobial. So add sulfur dioxide to avoid getting re-fermentation. And also, it depends on how long those wines are going to be aged before provided to the consumers. If it's aged for years and years, you will need to add a little bit more SO2 than if it's meant to be drank in a year. And also the pH. So pH, you know now, that's really important to know which form of SO2 you're going to have and how much you will need to add. So let's move to the demonstration. So we're going to measure free SO2 right now, and also we did prepare some total SO2 for those two wines before the beginning of the workshop, just to discuss the value we have. We didn't talk about lab safety and best practices yet, but the first thing you need to do when you start planning to do aeration-oxidation, that's making sure you're going to be safe, because that method is using a lot of acid. So it's using acid, phosphoric acid, which is corrosive. It's using sodium hydroxide, which is a base, but that's also very corrosive. It's using hydrogen peroxide, which is an oxidizer. And so that's pretty bad as well. So make sure you have the protection, personal protective equipment, which is, so for us, you can probably see that I have the lab coat. That's because we are in a chemical lab, chemistry lab. So we wear everything. We also wear gloves. And so the gloves, that's the most important part, because you don't want to have phosphoric acid or sodium hydroxide in your hands, or hydrogen peroxide in your hands. So make sure you have all that, those gloves. Also, you will need to have goggles. And so goggles, that's really to make sure you don't have anything coming to your eyes. Because if you have, once again, if you have sodium hydroxide or phosphoric acid in your eyes, it's going to be really, really irritating and pretty bad. So make sure you wear protective equipment. You will need some water. So we always use those fancy pipettes. So that's DI water, just to rinse all the equipment, all those systems, to avoid having any crystals, anything that will build up. Also, we use a burette. Also, you will need a recording, a data recording document. So today you're going to have to record the initial volume of sodium hydroxide you have in your burette, as well as the final volume of sodium hydroxide in your burette. And you will be able to make the calculation for free and total volume, so total volume used. And then you will use that data to calculate how much free and total SO2 you're going to have. Also, make sure you read the safety data sheet for all the chemicals you're going to use. That's really to make sure you know what to do with those wastes, because some chemicals you can combine them, some you cannot combine them, because they are so reactive that could explode in the worst case scenario. So just make sure you have you follow those safety data sheet. And also make sure you don't put everything in your sink. And that's because to protect the aquatic life and to protect everybody, make sure, yeah, if that's wine, just wine, you can put that in the sink. But if it contains the hydrogen peroxide or sodium hydroxide or phosphoric acid, don't do it, please. All right, so now we're gonna start by that system, so AO for short. What you will need to do or to have before starting anything. So as I said, we're gonna start by measuring free SO2. So you will need this system. So it's composed of a pipette, a glass pipette here. And that's just to make sure air is gonna go into, so you will have a flask that's going to be tight at the bottom. And that pipette is just to make sure air is going to make bubbles. You're going to have air, or you're going to have bubbles happening in that flask. So this flask, that's the G on your handout. G flask, that's where you're going to have your samples of wine that is going to be acidified. And so I just put G just to make sure I remember where it's supposed to go, because you will have exactly the same flask to put on the top here. That's the D. So G will contain acidified wine. That's going to be connected to that tubing, empty tubing. That's also connected to a system where you have water that is going to go through. So water has to come in at the bottom and will go out at the top. And that's really just to make sure when you start using heat for total bond or total SO2, you have all the vapor, all the gas, because you're going to form gas, that's going to be going through that tubing, and that's not going to be too hot. So that's to cool down a little bit the inside. So in at the bottom, out at the top. And so that means you will have to be connected to water. You can connect to tap water, but you might have some, it's better to have DI water if you can. And also, so that tubing is going all the way here. And you can see that you also have a tubing here, and that's to connect to airflow. So we have a system that's the AccuFlow. And so that's just to make sure you have air that is sucked here under a specific flow rate. So this system is going to have a flow rate of 1 liter per minute that you can adjust, but you will need to make sure that's always at this flow rate for accuracy. And also in our system, we have a timer, and that's because we're going to use that flow for 15 minutes. If you don't have a timer on this system or in the airflow system, that is fine. You can use a phone, you can use a timer on the side, just making sure you keep being consistent. So you always do it for 15 minutes. So at the bottom of this, you're going to have that flask D. So D flask, exactly the same as the other one. That will be fixed here. And that's where you will have hydrogen peroxide with a little bit of sodium hydroxide, but mainly hydrogen peroxide. And the goal is to have the molecular SO2 that is going to be transported from the acidified wine, that will be transported to that solution of hydrogen peroxide. And that's really just to form the sulfuric acid. So the reaction is going to be molecular SO2 plus hydrogen peroxide is going to form sulfuric acid. And that sulfuric acid that we will obtain, that's what we will do. We will measure using titration with sodium hydroxide. All right. So to start, you will need a few different things. First, you will need some transfer pipette to transfer some phosphoric acid, but also the color indicator you will need. You will need also some pipette and the pipette pump that you should have now. So that just to be specific and precise in the volume of wine and volume of hydrogen peroxide we're going to use. So you will just plug those two, and that's what you would use. All right, so you use that wheel to pipette the correct volume. We will use 20 milliliter of wine. So I have only a pipette of 10 milliliter. That means I'm going to pipette twice. I will make sure I always use the correct volume. So on one side, it's written 0. On the other side, it's written 10. But make sure you use that wheel to suck the wine. And then to release, you push here. So then you will need your wine sample. So if you have your the wine that we shipped to you last week, you can reuse it. Know that it has been open for a week now, even more maybe. So the concentration might be a little bit low. Otherwise, you can use the Pinot Noir that you have, or another wine that you have. The concentration of phosphoric acid, that's probably not easy to see, but that's 25% phosphoric acid solution that you will need. You will need a solution of sodium hydroxide, NaOH, and the concentration or the strength is going to be 0.01 normal, which is less concentrated than what you use for titratable acidity. So if you don't have this solution standardized, you will need to standardize that solution. And that's really important to be accurate in the concentration of free SO2 and total SO2 you're going to measure. So make sure you have 0.01 normal sodium hydroxide. Also, you will need to have a color indicator. And so you can see that's pretty dark green. And yeah, that's really difficult to see, but really dark green color indicator. if you don't have it already prepared, you can make it at home or in your winery. So that's a mix between methylene blue and methyl red. So it's two compounds that are combined together in a ethanol water solution. And so that's what you would use to look at the color change. So make sure you have those three solutions ready. Also, so before starting to measure free SO2, that's really to look at how much volatile or free, so everything that is not bound with any other compounds, you have in your wines. So to avoid getting anything bound released, you will need to have your G flask in a glass or in a cold environment. Because if you heat, that's how you're going to release the bound SO2. And so today we're going to start by free SO2. So make sure this flask is cold. So in this flask, that's where we're going to have the wine. In the other flask, that's where we're going to have the hydrogen peroxide solution. So let's start by the hydrogen peroxide solution in the other flask. So to do so, we need to take hydrogen peroxide. So use a pipette. You will need to take 10 milliliters. So use that pipette of 10 milliliters. Hydrogen peroxide solution should be, could be 3% or 0.3% or 30%. So that's the solution we use. I believe you can find hydrogen peroxide in pharmacy. So you can find that there. So I'm just gonna pipette 10 milliliters. And so make sure you are accurate in your volume. So you're gonna come with your eyes in front of that line, and you need to make sure the meniscus, the bottom of the meniscus has the correct volume. All right, so I'm just transferring 10 milliliters. Then make sure you keep that pipette straight, because if you move it, you might have some going into your pipette pump. So because you want to keep your pipette pump, make sure you don't turn in the other way. Then we need the color indicator because that's how we're gonna see when it's done, and that's how we're gonna do the titration based on color. So to do so, I will use a plastic pipette, and I'm gonna take 3 to 4 drops of that color indicator. And so you will see that the goal is to have a clear pale green. You will see it's gonna be, oops, and I put a lot, but you can see it's not green, right? So to make sure it's green, we will need to add some sodium hydroxide solution, because right now that's really purple. So I'm just gonna add a few drops of sodium hydroxide, so NaOH of 0.01 normal. And that's gonna be addition of sodium hydroxide until I reach the pale green color. And so I need to make sure I stir all the time, because if I don't stir, I won't see the color change. All right, so I've got the pale green. So I won't add more. And that's the cylinder I'm gonna attach here. To do so, you will use clamps, and you will make sure you clip here. So one thing to note is everything is in glass, and so glass can break. So make sure you you know where is the first aid kit, and you know what to do in case of you cut yourself, or in case of glass that broke. So in that other flask, the cold flask, that's in cold temperature, that's where you're gonna have your wine. And so we're gonna do the wine that we shipped to you last time. So you will use a pipette as well. I'm trying to, yeah. So you will need 20 milliliters. So once again, I'm gonna pipette twice, just making sure I have 20 milliliter. So once again, just making sure I have not enough, but not too much, but enough. All right, so I just transfer and then redo it. And this step, you should be pretty quick, because what we want is to evaluate how much free SO2 we have, which is pretty volatile. And so if you wait too long, that's when you're going to lose a little bit of sulfur dioxide. So make sure you do it quick. And quick, it's not a matter of seconds, but more of minutes. So don't wait like 15 minutes before finishing everything. And then in this wine, so you can see already the color is pretty brownish, or like red, but brick a little bit. So now I'm gonna add some phosphoric acid to acidify the wine. Because if I don't acidify it, I won't be able to evaluate how much free SO2 I have. The molecular SO2 won't be here, won't be very concentrated. So I use a pipette just to make sure I have 10 milliliter, not more. And I will just transfer directly into that volumetric flask, into that flask. You can see that after shaking, the color is a little bit more pink or more clear red. And that's because of the anthocyanins that we have in red wines. They are impacted by the pH of wines. So once you have it, just use the other clamp, right? And fix it. And if you can keep it cold, that's the best. So in our case, we're using a beaker with some ice. If you do have ice, make sure you keep it in ice. Once everything is set up, make sure all the connections are correctly made. Because now we're going to start the flow. And so the goal is to have air sucked here to make sure it's going to bubble. The air is going to go back to that solution of hydrogen peroxide. So I'm going to turn on and I'm going to start 15 minutes timer. When I turn, I have to make sure the flow rate is correct. So you have 1 liter per minute. That's the flow rate you should use. You can adjust with that wheel. And then you're just going to wait a little bit. So you can already see that the color changed from pale green, which is a little bit surprising, but pale green to purple already. So we're going to wait 15 minutes before doing the titration of free SO2. So that's really free SO2 we are doing right now. So while it's running, because we have 15 minutes to wait. So what we have been doing, preparing before the workshop was total SO2 for the 2 wines we have. So we did run total SO2. So we did heat directly that wine. And just by heating directly, that's how you measure total SO2. So you heat, and that's what you obtain. So at the end of heating, I had that color. So once you have that, so this color, this solution was coming from this flask after total SO2 analysis. So once you have that, you're going to do a titration with sodium hydroxide. What we are doing is measuring how much sulfuric acid we have in that solution. So to know how much sulfuric acid we have, we're going to do a titration. To do a titration, you need first to have a burette. So burette, that's this system where you have a tap here. So to open and to release few drops. So make sure it's closed before starting to do anything. And then you have some graduation on top of it. And so the graduation, that's what, so let me put it back straight. Graduation, that's where you will need to look at really straight. So your eye should be at the bottom of the meniscus, just making sure you read correctly. Sometimes, depending on the burette, you might have, so I have a 50 milliliter burette. So my numbers are starting from 26 is at the bottom, and then 25 is up. Or here it's 40 and then 39. Depending on the burette, that might be the opposite. So you might have 40 and then 39. So make sure you read in the correct direction. So I have to bring some sodium hydroxide solution first in that burette. So that's going to be the sodium hydroxide solution of 0.01 normal, the same that I use to adjust the color of that flask D. So to add into your burette, you can use a funnel. Sometimes that's safer than if you just do it by hand like that. So just a funnel, I just transfer. I'm gonna have probably 20, hopefully. All right. So I don't add sodium hydroxide all the way to the top because I'm just gonna measure a few samples today. But if you plan to do more samples, if you plan to do 10 samples, you might need to add more sodium hydroxide in your burette. So you have sodium hydroxide. Now, the first thing you need to do before starting any titration is looking at what's the initial volume of your sodium hydroxide solution. So to me, I have, and that's where you need to come on top, up. So your eyes should be right in front of the meniscus, the bottom of the meniscus. So I have 17.7. All right. Sorry, it's moving. So you record that initial volume, 17.7. Now you're going to start the titration of this total SO2. So I take that flask, and at the bottom, I come just on the bottom. And I'm going to add few drops until the color comes back to green, pale green. Make sure it doesn't touch the walls. And so you can probably see that I have, no, you don't really see, but it's pale. It's pretty purple, but it's turning green, right? All right. And so I did add enough sodium hydroxide. So now that it's back to pale green, I'm going to record the volume on my burette. That's going to be the final volume of sodium hydroxide. And I currently have 18.1. So to know how much total SO2 I had, or I have in that sample, I will do the subtraction of 18.1, which was my final volume, minus my initial volume, which was 17.7. And this value will be multiplied by a factor of 16. This factor of 16, that's only when you use sodium hydroxide of 0.01 normal. If you use another strength, you're going to have to multiply by the strength of sodium hydroxide. But here, that's only the final volume minus the initial volume times 16. And that's going to provide me a total SO2 of 6.8 ppm. You can see that's not very much. So in this wine, I have 6.8 ppm or milligram per liter of total SO2 in that wine. I can do the same on the Pinot Noir that we had also, because it's still running. The free SO2 is still running, so you still have time to do other things. So let's start again. Now I have, so 18.1, nothing changed, but that's also good to check that the volume is still the same. So 18.1 is my initial volume. I have total, the results of total SO2 in this flask. So I'm going to do the titration. I will just go at the bottom and add some sodium hydroxide, drop by drop, and stir. Make sure you stir all the time, because if you don't, that's going to lead to an error, because that won't be homogeneous and the change of color won't happen very much. So here I add a little bit more than the other wines, and that's probably because that's a fresh new bottle of wine, of the Pinot Noir. So we are looking again at total SO2 of this Pinot Noir wine. And so I keep adding and stirring. If you have a stir plate, you could have it on a stir plate with a stir bar. If you don't, you can just do that by hand. All right, and it's taking a little bit more than the other wine. All right, and it's back to green. All right, so same final color, but not exactly the same volume. So now I did the titration. I will record the final volume I have, and I have 22.6 milliliter of sodium hydroxide. So same, I'm going to do exactly the same calculation. So 22.6 minus 18.1 gives me how much total SO2 I have in this Pinot Noir wine. And so I have 72 ppm, so 72 milligram per liter of total SO2 in the Pinot Noir wine. It's almost done. I think we have 1 minute on the timer before the free SO2 is complete. So while it's finishing, just few things that can happen. So here, as I explained, free SO2 is measured by that's the amount of SO2 that is transported here, and that is reacting with the hydrogen peroxide solution to form sulfuric acid. So we're looking at how much sulfuric acid is obtained. But in a wine that has a lot of acetic acid, that's also a volatile acid. And so if you have too much acetic acid, that might interfere in the titration. So that's one thing you don't want to have, is too much acetic acid, or at least know how much acetic acid you have initially. Another thing is about the anthocyanins. In a red wine, red wines are rich in anthocyanins because they are the pigments, the red pigments, and those are forming bonds with the sulfur dioxide, but those bonds are pretty weak. And so you might have an overestimation of free SO2 because of those weakness, like because of that weak bonds. That's pretty easy to break, those bonds. And so the release of SO2 can also come from those bond SO2 with anthocyanins. So that's one thing to really know. Right now it's done. So the timer is off. I'm just gonna turn off that system. So we're gonna do exactly the same thing in terms of titration as for total SO2. So we're gonna grab that flask D. So I open the clamp, make sure you hold that piece at the same time, otherwise everything is gonna fall down. And once again, you don't want to cut yourself, so So you keep that flask and you can see it's really purple. That was the wine we did provide to you last week. And so same as before, I'm just gonna take that, flask at the bottom of the burette. But before, I'm gonna record the volume of my burette. And once again, it might have changed. So I want to make sure that's the same. I have 22.7, 0.6, sorry, 22.6. So I record 22.6. Oh, Alex is recording 22.6. And then I come with that flask at the bottom of the burette and I add, so drop by drop. So I open the tap and I add a little bit until, look at that. It's back already to green. And so I record again the final volume I have on in my burette, and I have 22.8. 22.8. That's my final volume. I'm just gonna throw that away now because I want to do bond SO2. And so I'm just gonna keep using that wine, acidified wine, but I'm gonna heat to release the bond SO2. But I need to prepare a new solution of the D flask. So just gonna put that in the trash. I'm gonna clean that flask with some DI water, just making sure you don't have any more sodium, hydrogen peroxide, sodium hydroxide, all of those. So clean, make sure you have a trash, like a beaker, that is the trash. At the same time, I'm just starting the heat and I'm removing that glass beaker because I don't want to have everything exploding because heat and cold, you know, they don't like each other too much. I also have on the side, so I have that system, which is a heating system. And probably you have that. If you don't have exactly that, that is fine, as long as you have a way to heat that cylinder. So I have a heater. I just turn on that heater. So it will take a little bit of time to heat, but that's just enough time for me to keep preparing everything. So while it's heating, I'm gonna prepare again that flask that's gonna contain hydrogen peroxide and a little bit of sodium hydroxide. So in this flask, I'm gonna add 10 milliliter of hydrogen peroxide again, so with that pipette. And so I'm just gonna start. So I take 10 milliliter. That I transfer directly into that cylinder. I remove before putting that pipette pump away. That should, yeah, that becomes hot. So I'm just, don't burn yourself because same heat has risk. So don't burn yourself, that's not the goal. Okay. So in that flask, we have hydrogen peroxide. We need to put the color indicator, so a few drops of color indicator. Until the color is pale green, but it might be not pale green at first. Yeah, it's 3 to 4 drops of that color indicator. But you see it's more purple than pale green. So I need to add some sodium hydroxide to make sure it's back to the correct color. So I use the same solution that is in my burette for the titration. I use a pipette again. And few drops. I might need to add more than color drops of than color indicator. But so make sure you stir, and that's back to pale. pale green. Up. All right. Once you have it ready, you can use the clamp, always hold, and put it here. All right. So this is heating. That's what we need. If we heat, that means we need to have some water running through just to cool down everything. So I'm just going to start the water. Oh. And you might have leak somewhere, but make sure you don't have leak anywhere in your system here. So the water should go from the bottom and back to the top. So from the bottom and goes to the top. All right, once everything is ready, so set up, you can once again turn on your IQ flow or your airflow. Put 15 minutes. And make sure the flow rate is 1 liter per minute. And it's gonna run for 15 minutes. And that's where we're gonna measure bound SO2. So as I just explained, to know how much free SO2 or bound SO2 or total SO2 you need, you're gonna have to use the final burette reading. So the volume of sodium hydroxide final you had, you subtract by the initial volume in your burette and you multiply by 16. This multiplication by the strength of sodium hydroxide, that's only if you didn't use 0.01 normal. If you did use 0.01 normal, you just do that first line of the equation. For us, we had 3.2 free SO2, and that was from the wine that was open a week ago, and even longer than that. So that's the reason why we don't have that much free SO2. Also, we were able to know how much total SO2 we had, and we had 6.8 ppm. So you see, that's really, really low. That might be risky to keep having that wine. If that was a wine that was just at bottling, I'm going to explain how much SO2 we will need to add to make sure it's protected. Because right now, 6.8 ppm, that's in a wine that was open, so it's not a big deal. But if that was at bottling, that would be really too low. For Pinot Noir, we had total SO2 of 72 ppm. But hopefully you learned a little bit about that system and how it is, how it works. So there are pros and there are cons. The pros of using that method is really robust. It's really a reliable method. But at the same time, that's really time consuming because you need to spend at least 15 minutes per sample to run free SO2 or to run total SO2. If you want to run free plus bound SO2, you're going to have to spend 30 minutes minimum to run one sample. So it's time consuming. It's not really time efficient. Also, another cons would be the flow rate. So you need a flow rate that is really specific and precise. So you need a 1 liter per minute of flow rate of airflow. But if you don't have that airflow, you're going to have some fluctuation of the reaction. And so that won't be really accurate. So you always need to make sure you have everything done correctly. Also, one other, so as I explained a little bit earlier, so acetic acid that's volatile, that can be interfering into the calculation or in the concentration of free SO2 and total SO2 overall. Also, anthocyanins can lead to some overestimation of free SO2. But that's just the thing that you need to know. Another source of error would be the strength of sodium hydroxide, in the sense that if you don't use exactly 0.01 normal, let's say you prepare your own concentration of sodium hydroxide, you will need to standardize that. Because if you don't, you're going to have a value, a strength that is not going to be accurate. And when you do the titration, you will not have the correct value of titration. So you need to make sure everything is standardized And if you create your own solution, you standardize your solution before making any calculation. So once you have identified how much free SO2 you have in your samples, you will then need to potentially add sulfur dioxide, and so free SO2. So to do so, you need to know the pH of your wine. In our situation, we had the pH of the wine we shipped last week was 3.70, so 70. And the Pinot Noir was a pH of 3.59. So on this table, you have the concentration of each individual form of free SO2 for each pH. So you see that the lowest the pH, so 2.9, is going to lead to a lot of molecular SO2, a lot compared to 4.0, but also a lot of less bisulfite form. And overall, that's just telling you how much free SO2 you will need to add to have a concentration of molecular SO2 of 0.8 ppm. And that's really based on how much antimicrobial activity you would need. So you see that if you have a pH of 2.9, you will add just 11 ppm of free SO2. But if you have a pH of 3.8, you will need to add 79 ppm of free SO2, which is pretty important. That's why making sure in your wine you have a pH that is pretty low, that's better to avoid adding too much sulfur dioxide, because once again, you have legal limit. You can have excess of SO2 that leads to that burning match. So you don't want to add too much neither. And that's where it's challenging to identify which concentration do you really need to add to avoid having too low and too much. So you need to know the pH of your wine or your must. And then you need to know how much free SO2 initially you had. And then what type of wine do you have? Is it a sweet wine where you have a lot of residual sugar? If so, you will probably have to add more than planned or expected, because those sugars are able to bind with SO2. And also you want to make sure the microbial activity or antimicrobial activity is really there. If that's a white wine, you will need to add a little bit more than a red wines, because as I explained initially, in red wines, you have those tannin phenolic compounds that are preservative as well. They are antioxidant. So in red wines, you're gonna tend to add less SO2 than in a white. How much do you need to add in your wine? So let's say you have, so just as an example, you're gonna use potassium metabisulfite. That's one of the most commonly form of SO2 that we use in wineries. So that's KMBS. KMBS contain 57.6% of SO2. So this is really important in the calculation, in the math, for the addition of SO2 you need to make. So there is a specific equation that you can see here to know how many grams of potassium metabisulfite you need to add. So in the example of a wine that has a pH of 3.80, if you go back on the table, so pH of 3.80, we would need to add 79 ppm of free SO2. So let's say we want 79 ppm of free SO2. We are going to multiply that by 3.785, which corresponds to the factor of, that's the conversion factor between liters in gallon, or gallon into liters. So for those calculations, we always use the international system. So 3.75 liters correspond to 1 gallon. Let's say we want to add potassium metabisulfite in 100 gallons of wine. So we're going to multiply 79 ppm of free SO2 we want to add times 3.785 times 100. And then we will divide everything by 1,000, which is just to convert between milligram to gram, and multiplying by the percent of SO2 that is in potassium metabisulfite, so by 0.576. So when we do that, if we want to add 79 ppm of free SO2, because the pH of our wine is 3.80, we did the calculation, and that means you're going to have to add 45.3 grams of potassium metabisulfite. That's just an example. Or 51.9. Okay. So 51.9 grams. If you want to add 79 ppm of free SO2. However, as I mentioned a little bit earlier, you need first to check how much free SO2 you already have in your wine. And so if you think that you have, or if you measure, let's say you have 10 ppm of free SO2 already in your wine, that means instead of adding 79 ppm of free SO2, you're going to subtract to 10 ppm of free SO2 that is already present. And you will need to add 69 ppm of free SO2. So when you do that math, that's how you come with 45.3 grams of potassium metabisulfite to add. Also, you will need to keep in mind that out of that 49.3 grams of potassium metabisulfite you're going to add, so free SO2 you're going to add in your wine, about 30% to 50% of that is going to bind with other compounds. So it's going to bind with anthocyanins, it's going to bind with sugar, it's going to bind with acetaldehyde. So it's going to be considered as bond. And so to be really efficient, you will need to add you will need to consider that 30 to 50% of binding. So of those 45.3 grams of potassium metabisulfite, you're going to multiply by either 30% or 50%. If you multiply by 50%, that means you're going to have to add about 22 grams or 22.6 grams more potassium metabisulfite. So you're going to come up with a total of 67.95 grams of potassium metabisulfite to add. If you have any other questions, feel free to email me. I will be happy to help. Also, there are a lot of different tools and fact sheets that are available on the ISU extension store. So make sure you look at that website. We just made a fact sheet a few months ago on sulfur dioxide analysis in different red wines and white wines from non-vitis vinifera wines. We did compare the different methods. So we did compare Vinmetrica, we compared with AO, we compared with Megazyme, that's another new technique, with the gas detection tubes. So there is a lot of information on that website, so feel free to go through it, and you might find a lot of information in that. And so to finish, I just want to thank you all for your participation and all your great questions. I hope it was helpful and you learn about how to use those different systems, what are the pros, what are the cons, and how to do those analyses. I want to thank Iowa State University Extension and Outreach for the funding support, who did provide us a lot of help for making all those virtual live workshops in place. We thank the Institute for providing the AO system. And also there is a workshop, a survey that we will really appreciate your feedback, because we try to evaluate what we need to change. If you need to have an in-person workshop, if you really need that, let us know. If you want to have other virtual live workshop, if that's a good way for you to learn, let us know. So please just use either the QR code or the link that I think is shared on the chat box. So make sure, yeah, please, really, that's really helpful for us. And if you don't help us, unfortunately, I don't know how we would be able to continue to provide you all the help you might need. So thanks again, and hopefully we will see you soon for other workshop. And if you have suggestions of topics, feel free to put that into the survey. Thanks, everyone.